Hello everyone, hope all are doing well. So welcome back to the learning field. So we are continuing the LPB lecture series. Okay, so the LPB lecture series is very helpful for GATE mathematics, CSIR NET mathematics, and any other exams which in which the LPB syllabus were included. Okay, LPB syllabus included. Okay. So let's get started, and before starting I am requesting you to all those who are new, those who are watching me for the first time, please like, comment, share and subscribe the channel. And in this lecture we will discuss the VAM method. Okay, that is the Vogel Approximation method for solving the transportation problem. Okay, so we already discussed the three methods, that is northwest corner rule, 3 or 4 method: northwest corner rule, row minima method, column minima method, and matrix minimum method for finding the initial basic feasible solutions. Okay, so basically the Vogel approximation is another method in which we find the initial basic feasible solution, but among these processes or among these methods, VAM is the most improved method, you can say. And if we find the cost, or if you find the transportation cost from the any 4 or 5 methods, then we find the minimum most cost in the Vogel approximation method. Okay, so you can say that this is that's why this method is called the improved method to find the initial basic feasible solution for the LPB. Okay, so in this video we will discuss the VAM method or Vogel's approximation method and the optimality test for the variable for the transportation problem, and the optimality test is also known as the Modi's method or Modi test. Okay, so let's start. So first we discuss 4 types of different types of transportation problem. Okay, so unbalanced transportation problem we already discussed this. Okay, so if summation Aij is not equal to summation Bij, then it is called the unbalanced transportation problem. Transportation problem of maximization, if in the question we have to solve the maximization of the transportation problem, we first change the sign of the each elements of the matrix of the transportation problem, maximum of z equal to minus of minimum of minus z, and then find the solution. Okay, then considering the problem as a minimizing problem, we solve it and find the minimization of minus z. Okay, no allocation will be made in the practice cell, particular cell. Okay, so it is required that no allocation can be made to the particular cell, say Ij. That is, if there is no allocation, that is there is no cost allocation, then assign a large possible number m as the cost Cij on the cell. Since m is larger, so no allocation will be made in the cell Ij. Okay, so I think it is clear. क्या करना होगा यहाँ पे? सो सपोज यहाँ पे जो ट्रांसपोर्टेशन प्रॉब्लम है, सपोज ये एक ट्रांसपोर्टेशन प्रॉब्लम है, सपोज इस सेल में कोई एलोकेशन नहीं है, ठीक है, तो यहाँ पे क्या करेंगे हम लोग, यहाँ पे एक कैपिटल एम लेंगे जो कि होगा क्या होगा, मैक्सिमम नंबर होगा. देन क्या होगा, सिंस ट्रांसपोर्टेशन प्रॉब्लम मीन्स व्हाट, मिनिमाइजेशन प्रॉब्लम, देयरफॉर दिस कैन नॉट बी द सॉल्यूशन बिकॉज दिस इज द highest number. Okay, so that's why we takes the positive number as highest number as the cost. Okay, so this is the no allocation cell, and the decreased cost coefficient or the cell evaluation of delta ij for the cell Ij is defined by delta ij equal to Cij minus ui vj plus vj, where ui and vj are the arbitrary chosen cost parameter. Okay, and one more important thing is that degeneracy. Okay, a transportation problem m with m origin and n destination has degenerate basic solutions if any one of the m plus n minus 1 basic variables is 0, that is the number of unoccupied cells is less than what, m plus n minus 1. Okay, I think just a minute. Okay, so this is the solution of the degeneracy. Okay, now let us take the Vogel approximation method. So basically in this method we also find the initial basic feasible solution for the transportation problem. Okay, so the steps for the Vogel approximation methods are: step 1, write the given transportation problem in the tabular form if it is not given. Okay, step 2, compute the difference between the lowest cost and the next lowest cost corresponding to each row and each column, which is the most as the penalty cost. Okay, so क्या करना होगा, फर्स्ट टेबुलर फॉर्म में लिखना होगा, देन जो रोज है एंड कॉलम्स है उसमें से क्या करना होगा, लोएस्ट कॉस्ट को फाइंड करना होगा एंड सेकेंड लोएस्ट कॉस्ट को फाइंड करना होगा. ओके, and exhibit the next against the respective rows and columns, okay, parentheses in the transportation table by the side of availability and the below the demand रेस्पेक्टिवली. दैट मीन्स क्या होगा, ऑल जो कॉलम्स है एंड ऑल रोज में यही एक ऑपरेशन अप्लाई करना होगा. दैट इज क्या करना होगा, जो लोएस्ट कॉस्ट है एंड जो सेकेंड लोएस्ट कॉस्ट है वो हर एक मतलब रो एंड हर एक कॉलम में फाइंड करना होगा. ओके, सो नेक्स्ट स्टेप इज चूज द ग्रेटेस्ट ऑफ ऑल दिस रोज एंड कॉलम्स डिफरेंस. सपोज the corresponds to the ith row, choose the cell with the minimum cost in the ith row. Okay, if the maximum difference corresponds to a column, then choose the cell with the minimum cost that column. Okay, so यहाँ पे क्या करना होगा, ये जो greatest of choose the greatest of all these rows and column difference, ये जो difference हम लोग निकाला है इसमें से greatest जो होगा difference को निकालना होगा. ठीक है, तो step 4 क्या है, let it be the ij cell, then allocate minimum of ai bj to this cell. Okay, so यहाँ पे allocate करना होगा. if minimum of ai bj is ai bj equal to ai, then the availability of the, ये तो हम लोग पहले ही पढ़ा है. ठीक है, so we discuss these topics and just यहाँ पे these two steps are important steps. Okay, for the Vogel approximation method and the remaining steps are the same as the previous method. Okay, so जो किया था हम लोग. ठीक है, एंड नेक्स्ट जो आते हैं हम लोग ऑप्टिमलिटी टेस्ट. ओके, सो द ऑप्टिमलिटी टेस्ट, देयर आर सम स्टेप्स टू फाइंड द ऑप्टिमल सॉल्यूशन ऑफ द ट्रांसपोर्टेशन प्रॉब्लम. ओके, सो द मेथड्स, द 5 मेथड्स वी ऑलरेडी डिस्कस्ड, दैट इज द नॉर्थ वेस्ट कॉर्नर मेथड, देन रो मिनिमा मेथड, देन कॉलम मिनिमा मेथड, देन मैट्रिक्स मिनिमा मेथड एंड देन VAM method, that is Vogel approximation method. These 5 methods are to find the what initial basic feasible solution for the transportation problem. Now the solution we have find, that is the initial basic feasible solution को improve करना है optimal solution में. ठीक है, तो ये कैसे करेंगे हम लोग, इसका जो स्टेप्स है, ये जो ऑप्टिमल टेस्ट है इसको मोदी टेस्ट भी बोलते हैं. ठीक है, MODI मोदी टेस्ट. ठीक, तो मोदी टेस्ट भी बोलते हैं इसको. ठीक है, तो देखो स्टेप 1 क्या करना होगा, कंस्ट्रक्ट द बैलेंस ट्रांसपोर्टेशन प्रॉब्लम, देन डिटरमिन द इनिशियल बेसिक फेजिबल सॉल्यूशन वन बाय वन, determine ui vj I equal to 1 to m, j equal to 1 to n such that for the occupied cells this. तो इस रिलेशंस को यूज करके ui एंड vj का वैल्यू कैलकुलेट करना है, क्योंकि ये cij गिवन होगा. cij क्या होगा, द कॉस्ट कॉरस्पॉन्डिंग टू दैट सेल. ओके, ऑक्युपाइड सेल. तो स्टार्ट ui इक्वल टू 0 फॉर द ith रो कंटेन्स द मैक्सिमम नंबर ऑफ एलोकेटेड सेल्स. तो क्या लेंगे, वी टेक द ui, दैट इज द कॉलम ui, this is equal to 0, corresponding to which, corresponding to that row in which the maximum number of allocations occurs. Okay, calculate the reduced cost coefficient delta ij by delta ij equal to cij minus ui plus vj. Okay, so this is one convention. The another books maybe take another convention, that is delta ij, this is equal to, you can take ui plus vj minus cij. These conventions are also taken by some other books. Okay, I use here these conventions. Okay, and in these cells clearly the occupied, for the occupied cells delta ij equal to 0. क्यों, क्योंकि डेल्टा आई जे हम जो ऑक्युपाइड सेल्स के उसके करस्पॉन्डिंग डेल्टा आई जे इक्वल टू 0 लेके ही हम लोग इसको सॉल्व करेंगे. ठीक है, सो लेट अस टेक द एग्जांपल एंड देन राइट दिस डेल्टा आई जे इन द स्मॉल सर्कल इन द अनऑक्युपाइड सेल्स. ओके, step 5, if delta ij greater than equal to 0 for all ij, then the total cost z dash corresponding to this reduced cost will be 0, because delta ij equal to 0 for the occupied cells and xij equal to 0 for the unoccupied cells. Okay, this is the reason. Therefore z dash equal to 0 is the minimum cost and hence z is minimum. Okay, thus the initial basic feasible solution is an optimal solution, that is the this minimize the objective functions or minimize the transportation cost, you can say. Okay, so these are the steps. I will share the PDF in the Telegram channel. You can find from the Telegram channel of the official Telegram channel of the learning field. Okay, and the step 6 is, if the initial basic feasible solution is not optimal, that is if in any case delta is less than 0, then select the cell which has negative most cell evaluation. If this is not unique, then select any one among them arbitrary. Okay, तो ये सिंपल मतलब लैंग्वेज में लिखा है. ठीक है, दिस सेल इज कॉल्ड द एंटरिंग सेल, as in the improved BFS some allocation will be made in this cell. Suppose PQth cell is the entering cell. Okay, step 7, identify a loop that starts with the starts and ends with PQ. That means यहाँ पे closed loop find करना है, but connect some of the basic cells. Okay. Step 8, assign the maximum value theta in the cell PQ and consequently subtract and add the interchangeably theta from the transition cells to the loop, so that the value of the basic variables becomes 0. Okay, so this is our motto. The basic variables are becomes 0 and the maximum value of the theta is selected among those xij from the theta is subtracted. Okay, so this is the simple language. The basic cell whose allocation has been made to 0 is called the departing cell. Okay, and step 9, repeat these steps 3, 4, 5, 6, 7 and 8 until the optimal basic feasible solution is obtained. Okay, so our motto is to show the delta ij is greater or equal to 0 for all ij. If this is satisfied, then the initial basic solutions obtained by the Vogel's approximation method is optimal. If this delta ij is less than 0, then we have to improve the initial basic feasible solution by the Modi's method, that is optimality test, and this is the total steps to find the optimal solutions. Okay, I think these steps are understandable, is very easy. Okay, so let's now take an example first. This example is very important. I discuss this example thoroughly, each and every step. Okay, so see this example very carefully. Okay, so the example says that find the optimal solution corresponding to the transportation problem, this one. So these are the sources and these are the destinations. Okay, so there are 3 sources or origin and 4 destinations. Okay, so first we see whether this transportation problem is a balanced transportation problem or not. Okay, so see summation ai equal to what? Summation ai equal to 70 plus 55 plus 90. So 70 plus 55 plus 90. So this is equal to what? 70 plus 55 plus 90. This is equal to 160 and 215. Okay, 215. Okay, so this and summation bj, this is equal to what? 85 plus 35, that is 90, 120 plus 50, 170 plus 45 is equal to 215. So since summation ai equal to summation bj, then this is a balanced transportation problem. Okay, so now we find the initial basic feasible solution by Vogel's approximation method. Okay, so see how can we solve this problem. Okay, so see, we first write the table here. Okay, so see, this is 6, 1, 9 and now 3, then 11, 5, 2 and 8. Okay, and then 10, 12, 4 and 7. Okay, so we first find the difference between the see here it is given. Okay, so we first find the difference between the lowest and second lowest cost of the row, and each column are written within the first bracket and exhibit them against the respective rows and columns. Okay, that means यहाँ पे क्या करना है, हर एक रो एंड कलम का जो लोएस्ट कॉस्ट है एंड जो सेकंड लोएस्ट कॉस्ट है उसका मिनिमम यहाँ पे लिखना है. ठीक है, तो लेट जस्ट लाइक रेट दिस. So this is given 70 and the minimum cost is 1 and second minimum is 3. So this is 2. Okay, the difference between the second cost and minimum cost and the second minimum cost. Okay, so there is 55 and there is 2 and 5. So this is 3 and this is 4 and 7. So 90 is given and this is 3. Okay, why? This is the minimum cost and this is the second minimum cost. Oh, okay, so this is the difference between second cost and the minimum cost and the second minimum most cost. Okay, so and now we apply this throughout the column. So 85 is given and this is 6 and 10. Okay, so minimum and second minimum का difference 4 है. 35, 1 and 5. So minimum and second minimum का जो difference है वो है 4. Similarly 52 and 4, 2 and 45 is given. Difference between the minimum and second minimum is at 4. So this is the first step. Then now the maximum of this 4 difference is 4. Okay, why? Because यहाँ पर 3 4 है. ठीक है, जो ये जो difference है टोटल जो difference है 7 difference है rows and columns का, यहाँ पे maximum difference क्या है 4 है, but 4 यहाँ पे unique नहीं है. 4 यहाँ पे 3 जो columns है उसका minimum 4 है. So we choose any of them. Okay, so there is no problem in here. Okay, so बट वी चूज कॉरस्पॉन्डिंग टू फास्ट, तो यहाँ पे फास्ट रो का चूज कर रहे हैं, वी सिलेक्ट द आर्बिट्ररी फास्ट कॉलम, ओके, फास्ट कॉलम को यहाँ पे चूज कर रहे हैं, ठीक है। मिनिमम ऑफ द कॉस्ट ऑफ द फास्ट कॉलम इज 1 1, ओके, सो वी चूज फास्ट कॉलम, ओके, हियर द फास्ट column, so this one. Now the minimum cost is what? Minimum cost is 6, okay, so we allocate here, so we allocate what here? Minimum of what? So x11, this is equal to minimum of the same process 85 and 70, so 85 and 70, so this is equal to 70, so here we allocate 70, this is 70, and therefore if we allocate here 70, therefore the total supply, that is from the origin O1 is exhausted, okay, so we cut it, and now we write here the remaining cost is what? Remaining demand for the destination D1 is what? D1 is the number of units, so this is one first step closed. Remaining demand is 15 units, and the others demands of D2, D3 and D4 are same, so this is 35, this is 50, this is 45, and this is 55, and this is 90. Now we apply the same process, that is we find the minimum of each rows and each columns, okay, so this column is exhausted, oh, sorry, this first row is exhausted, okay, so now we find the minimum of this 11 and 10, two numbers 1, 12 and 5, these two numbers is 7, and then 2 and 4 is 2, 8 and 7 is 1, and for this, for row 2 and 5, this is 3, and what, then 4 and 7, this is also 3, okay, so the highest difference is what? This 7, okay, so this is the entering vector, so and since this is entering vector, and now we find the minimum of this cost of this column, so this is the minimum cost, so we allocate here, okay, so this is the next allocation, okay, and here the cell number is x22, x22 equal to what? Minimum of what? This 35 and 55, so 35 and 55, okay, 55, so this is equal to 35, so we allocate here 35, so this is the allocation 35, okay, so we allocate here 35. Now what? The destination, sorry, the demand for the D2 is exhausted, okay, this is exhausted, so we cut it, and here the remaining supply from the origin O2 is what? Here 20 units, okay, this is 20 units. Now here 15 units remaining, and this is 1 only, this is exhausted, here 50 units needed for the demand, and minimum and second difference between minimum and second minimum cost is same, and here also 45 and difference is same, okay, and here 90 units needed and also same, okay, so this is 3, this is what? 2 and 6 and 11, 2, 8 and 11, so this is the difference between minimum and second minimum is 6 unit, okay, so this is the step 6 minimum. Now what? So the maximum allocation is here 6, okay, so in this row, so we find now the minimum cost, so this is the minimum cost, this 2, so we allocate here, we allocate the minimum of this 20 and this 50, so 20 and 50 का minimum क्या है? 20 होगा, so we allocate 20 here, therefore this cell is exhausted, okay, so this is the process in this table in the book, okay, so see after this step, this is exhausted, now we find what? Now we find this is the 15 units and 1, this is what? 20 units हो गया, यहाँ पे 30 units बाकी है, एंड यहाँ पर 45 यूनिट्स बाकी है, यहाँ पर 20 खत्म हो गया या 90 बाकी है, ठीक है, तो ये हो गया दो स्टेप्स. नाउ देन यहाँ पर क्या करेंगे, जो होगा ये है 4 ओनली 1, मतलब 4 ही है, तो यहाँ पे 4 ही लिखेंगे, 34 नहीं लिखेंगे, एक ही तो है, ठीक है. तो देन यहाँ पर क्या लिखेंगे, ये यहाँ पर भी सेम है एंड यहाँ पर भी सेम है. तो यहाँ पर देखो क्या होगा, फर्स्ट जो मिनिमम कॉस्ट है 4, यहाँ पे क्या होगा 30 एंड 90 का जो मतलब मिनिमम है, सो 30 यहाँ पर बढ़ गया, तो ये सेल खत्म हो गया, ये खत्म हो गया. देन क्या होगा, देन से जो मिनिमम है वो है 7, 30 गया यहाँ से, तो यहाँ से 45 एंड जो 60 था 60 एंड 45 का मिनिमम बढ़ गया यहाँ पे देखो, ठीक है। तो 60 एंड जो 45 का मिनिमम है, तो यहाँ पे 45 बैठ गया एंड ये खत्म हो गया। देन यहाँ पे 15 यूनिट्स, तो 15 यूनिट्स यहाँ पे यह बैठ गया, ठीक है। दिस इज द कंप्लीट प्रोसीड्योर, दिस इज द ब्रूक प्रोसीड्योर एंड राइट इट, आई डू इट हियर। ओके, सो हियर द कंप्लीट प्रोसेस इज रिटन विच इज एग्जॉस्टेड एंड जो स्टोरी है फुल यहाँ पे लिखा है, ठीक है। तो देखो, then after this VAM method we get the evaluation what, x11 equal to 70, x22 equal to this one the line, x22 equal to 35, x23 equal to 20, x31 equal to 15, x33 equal to 30 and x34 equal to 45. This is the evaluation and this is the initial basic feasible solution. Okay, so see, then since the number of allocation is 6, so 1 2 3 4 5 and 6, okay, number of allocation is 6 which is equal to m plus n minus 1. m का वैल्यू क्या है, m का वैल्यू है 3, n का वैल्यू क्या है 4, the order of the matrix. Okay, so there are 3 sources for destinations, so m plus n minus 1, so this is equal to 6 which is equal to number of occupied cells. Okay, so if this is equal, then the solution is the non-degenerate solution. Okay, so this is non-degenerate solution. We now test the optimality of this solution. Okay, so since now see in the this table, okay, so total जो maximum number of allocations है वो this थर्ड रो में है, ठीक है। तो थर्ड रो में है, तो क्या करेंगे हम लोग, यहाँ पे जो u3 है, u3 को यहाँ पर 0 लेंगे, ठीक है। तो ये मेथड में था। सो स्टार्टिंग विथ u3 इक्वल टू 0 एज द नंबर ऑफ एलोकेटेड सेल्स इज द मैक्सिमम इन द थर्ड रो, वी कैलकुलेट u2 u3 जो ऑक्यूपाइड सेल्स है उसका जो u1 एंड u एंड v को हम लोग यहाँ पे कैलकुलेट करेंगे। कैसे कैलकुलेट करेंगे, सो सी u3 this is equal to 0. Okay, now we apply the method Cij, this is equal to ui plus vj. Okay, first we write I equal to 3, since u3 equal to 0 we know that, so c3j this is equal to u3 plus vj. Okay, so now c3j, 3j means what, third row. Okay, so first if we write here the first v1, so c31 means what, c31 means 10. Okay, so we write here c, suppose we write c31, so this is equal to u3 means 0 plus v3. Okay, so c31 का वैल्यू क्या है, c31 का जो वैल्यू है वो है 10, यहाँ पर जो 10 है c31 कॉस्ट corresponding to the cell 31, so 10 equal to what, 10 equal to v3, so we find v3 equal to 10. Okay, so applying this method we find all the values of these occupied cells. Okay, u3 u2 v1 v2 v3 v4. Okay, so this is the method we can find. Now we find the allocations in the unoccupied cells. Okay, so these are the occupied cells, this is occupied cell, this is occupied cell, this is occupied cell, this is occupied cell, this is occupied cell and this is occupied cell. The remaining other cells are the unoccupied cells. Okay, we have to find all the delta ij's of all the unoccupied cells. If all the delta ij's are greater or equal to 0 for all ij that is corresponding to all cell, then we say that the initial basic feasible solution is the optimal solution. If not, then this is not the optimal solution, then we have to apply the optimality test or Modi test. Okay, so this is the method. Now here see, delta 1 2 is less than 0. Now we have to calculate delta 1 2. Okay, so how can we calculate the delta 1 2? We have to calculate all these unknown quantities, then we calculate the okay, so i3 means v3 तो हो गया, 2 3 लिखते हैं यहाँ पे, 2 3 this is equal to u2 plus v3, u2 sorry c23, this is c23, so c23, तो c23 का वैल्यू क्या है, c23 cost 2. Okay, okay, so c23 means 2, this is equal to u2 plus v3 का वैल्यू क्या है 10, so u2 equal to minus of 2 sorry u2 equal to minus of 8. Okay, u2 equal to minus of 8. Now if we find here it says that delta 1 2 less than 0, let us check whether delta 1 2 is less than 0 or not. Delta 1 2 equal to u1 plus v2, so we have to find u1 and v2 first. Okay, so we find all these elements, just a minute. We have to find all this. So we get V3, we get V3, we get U2, V3 U2, okay. Then U3 equal to 0 hai, okay. Then V1, that is C 31, this is equal to U3 plus V1, okay. So C31 equal to what? C31 equal to C31, this is equal to 31, 10 again, okay. So 10, C31 means 10 equal to U3 means 0 plus V1. So this implies V1 equal to 10, okay. V1 equal to 10. Now we calculate what? Now we calculate V1 equal to 10, we find. Now we write B2, okay. B2, that means C12, get U1, no, I think U2, so U23 लिखता है, U22, just a minute, U22. So U C22, this is equal to U2 plus V2, okay. So U2 plus V2, U2 means minus 8. So C12 means what? C12 means C22, this is 5, okay. So C22 means 5. So 5 equal to minus 8 plus V2. Since the value of U2 is here minus 8, so this is equal to V2, this is equal to 13, okay. So we get V2, okay. Now if we calculate U12, then what? U12, this is equal to C12 is equal to U1 plus V2. So U1 plus V2, that means U1 equal to what? C12 means, sorry, C12, so there is no allocation, sorry, this is unoccupied cell. C11 means what? C11 means U1 plus V1, okay. U1 plus V1 value 10. So C11 means what? Cost corresponding to 1 cell is 6. So 6 equal to U1 plus V1 का जो वैल्यू है वो क्या है? V1 का वैल्यू 10 है, ठीक है, this 10. So this is equal to plus 10. That means U1 equal to minus of 4. This we will get, okay. Now we have to find delta 12 means C12 plus U1 plus V2, U1 and V2, U1, okay. So see, we check whether this delta 12 here in this problem says delta 12 is less than 0, okay. So right, delta 12 equal to C12 minus U1 plus V2, okay. So C12 means what? C12 means cost corresponding to this, cost is this to 1 2, so cost is to 1, okay. So this is equal to 1 minus U1 plus V2, U1 plus V2, U1 value minus 4 and V2 is 13. So minus 4 plus 13, okay. So 1 minus 7, so this is equal to minus 6, which is less than 0. So this is the case, okay. You have to calculate all those things and calculate all the delta i's, okay. So this is less than 0, therefore the solution is not the optimal solution. Now we locate a loop with the cells 1 2, with the cells what? 1 2, the occupied cells. We take the occupied cells and unoccupied cells, okay. So we locate the loop with the cells 1 2 1 1 3 1. यहाँ पर क्या करना है, अब लोगों को एक लूप बनाना है, ठीक है, जो सेल्स है. एंड 2 2 वी एलोकेट द पॉजिटिव क्वांटिटी थीटा इन द सेल 1 2. सो यहाँ पर प्लस जो नेगेटिव आया डेल्टा 1 2, दिस सेल की कॉरस्पॉन्डिंग प्लस थीटा लेंगे, ठीक है. एंड अकॉर्डिंगली वी एडजस्ट द एलोकेशन इन द सेल्स 1 1, दिस इज देन 1 1 goes through 1 1, then this is goes to 3 1, then this is goes to 3 3, then this is goes to 3 2, then this is goes to 3 3, then this is goes to 2 3, then 2 2, then 2 1, okay. And this is the last, this last cell, okay. So this is the case. So 1 1 3 1 3 3 2 3 and 2 2, by subtracting and adding theta alternatively. Okay, so this is we take here for in the first cell plus theta, then minus theta, then plus theta, then minus theta, then plus theta, then minus theta, and this is the alternative. We take alternative plasma sign of theta. Okay, so now this is the loop which has been formed. Okay, now the maximum value of theta is obtained as theta equal to minimum of 70, 30 and 35. 70, this is the allocation, 30 what, 70, 30 and 35. Since these are the minus of theta, therefore maximum value of theta is obtained by these values. Okay, in the cells, the Xij values in which the thetas are negative, thetas with the minimum sign. Okay, I think this is clear. We take the maximum, we calculate the maximum value of theta by taking the Xij's, minimum of Xij's in which the theta belongs with a negative sign. Okay, so this is gives 30. Okay, now the improved solution is then x11 equal to what, x11, this is equal to 70 minus theta value is 30. So x11 is 70 minus theta means 30, this is equal to 40. Then x21, this loop is formed using the occupied cells. Okay, because we have to improve the we improve the initial basic feasible solution, that is, and initial basic feasible solutions are included the variables what, the occupied cells. Okay, so that's why the loop formed using the what, occupied cells. Okay, so x11 we have to cover all the occupied cells. Okay, so x11, then x31, this is equal to 15 plus theta, so 15 plus 30, this is equal to 45. Then this is 22, x22, this is equal to 35 minus theta, 35 minus 30, this is equal to 5, x, this is equal to 3 and 3, so x33, this is equal to 30 minus 30, 30 minus 30, this is equal to 0, and x23, this is equal to what, 20 plus theta 30, this is equal to 50. Okay, this is the solution. Now in this this is the solution. Okay, x11 equal to 40, 12 equal to 30, 22 equal to 5, 23 equal to 50, 31 equal to 45, and x34 equal to 45. Okay, so now we check all the delta ij's. This is equal to Cij minus ui plus Vj. Okay, if all the delta ij's are greater or equal to 0, then the optimality condition is satisfied. That is, the solution we have find, this is the optimal solutions. Okay, so if we write first occupied cells, these are the occupied cells. So we write first the occupied cells and then we calculate the unoccupied cells by using the same method. That is, first we solve the Uij is equal to Ui plus Vj by using the occupied cells, then find the Uij's, that is delta ij's by using the Uij, delta ij, this is equal to Cij minus of Ui plus Vj. Okay, now we calculate all delta ij's, or delta ij's are here greater or equal to 0, therefore the solution we already obtained is the optimal solution, this one. Okay, so this method is a very lengthy method, you can say, but this method is important. Okay, so these are the optimal solution and the optimal minimum cost जो होगा ट्रांसपोर्टेशन प्रॉब्लम का, वो तो corresponding ये जो cost and जो एक्सआईजेस है वो मल्टीप्लाई होगा and then उस मल्टीप्लाई का सम होगा and we get the 1160 unit is the answer. This is the answer. Okay, so I think this process is understandable. If there is any confusion, then you can comment me in the comment section below. This is the content for this video. Okay, this VAM method, I suggest that you can take, you must take any one of the problem from your book of the operations research, or from any book you can take any one problem and first solve the problems from examples, that is from your book. Okay, so and then take one or two problems of different types, you can take the problems with the cost. If cost is not given, then you can put here the m is the bigger number. Okay, then you can solve it easily. Okay, so this is the process. I think you can understand. You are understand. If you are not understand, then you can comment me. Okay, so if you like the content, please like, comment, share and subscribe the channel. Okay, thank you. See you again in the next video.